Hello and good morning, and today we are going to learn about trigonometry. And that's a mouthful, isn't it? Back in the old days, when there was no TV and no fun places to go to, no internet, the old Greek guys would be sitting around in their white robes playing with triangles and circles. Remember when they figured out that the ratio between the circumference and the radius, or the diameter, was always equal to some constant that they figured out to be pi. And there could be more on the planet Zork doing the same experiment or the same process and come up with the same number pi, which is like a universal number. Anyway, coming back to our topic of trigonometry, these old Greek guys would be playing with triangles and they figured out something else. They said, hey, you know what? Well, they already had angles worked out, and they said this was 0 degrees and that was 90 degrees, and somewhere in between was 45 degrees and so forth. And they'd used a 360-degree model to talk about circles and angles. And so these triangles that would get formed here, you'd look at a triangle here and they'd say, you know what? If this is the angle I'm talking about, and so, whatever this angle might be, let's say it's 30 degrees. They said, well, when this is 30 degrees, and if this is 4, then this is always 8. And so it looks like if I change this triangle, and I got another one, I know this is not to size, but let's say this was a 6 and a 12, well, that's the same ratio as these, and this angle would still be 30 degrees. So that means the angle depended on the ratio of the triangle sides. And they said, hey, there's something clicking here. So they created a system to relate each angle to each ratio. They say, okay, well, for 31 degrees, what angle do we get? For 32 degrees, what ratio do we get? And they figured out that it just depended on the ratio and not the size of the triangle. And this could be something powerful. And so they came up with a way to connect them. And so they used sine of theta, and theta is an angle. It's like x for angles. And so the sine of theta is always going to equal to, and they call this side, which was opposite to the angle you're talking about, the opposite. And this, of course, and don't ask me why, they always call the hypotenuse. So the opposite divided by the hypotenuse was going to be the sine of the angle. So sine was a way to connect that angle, which was 30 degrees, to the ratio 1/2, which is that 1/2, opposite, and that's the hypotenuse. And they also decided to call this guy the adjacent. Now this didn't just depend on the ratios of this and this, but also on the ratio of that to that, or ratio of that to that. And so for each of them, they came up with a cosine of theta, which was going to be the adjacent over the hypotenuse. And then finally, they came up with the tangent of theta, which is the opposite over the adjacent. Okay? And actually, sine of theta over cosine of theta is actually equal to tangent of theta. So they're kind of related in a way. And sine and cosine are also related. So everything's kind of related because it's all the same right angle triangle. Okay. So these are the three equations that we use. And when I was working with some kids, I'm kind of like an older guy. So I learned this a long time ago, and back then we didn't have any mnemonics. So I was working with some kids and I said, hey, you guys know how to figure this out? And they go, yeah, we use SOHCAHTOA. And I go, SOHCAHTOA? You're supposed to use trigonometry. I said, no, SOHCAHTOA. I was like, here, SOHCAHTOA says SOHCAHTOA. And this guy is basically talking about this equation there. And this guy is that equation there. And that guy is that equation there. Tangent equals opposite over adjacent. Cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. And so this is SOHCAHTOA. It's a way to remember all of this stuff real easy. So you could write this down first on your problem that you're working on, and then generate these three. And we kind of, use O over H if you like, something like that. Okay, so next video I'm going to show you how to use these to find, cool stuff about a triangle. This is really cool stuff because you suddenly have new abilities now. And you'll find out that all I need to do is give you two sides or an angle and a side of a triangle, or a right angle triangle, and you can figure everything out. So see you soon.